So in this question we have to show that the differentiation of e raised to power x with respect to x is e raised to power x. So how do we solve this kind of problem? From the basic definition of derivative or differentiation, what you maybe feel like, we know that basic definition of any function fx can be written as f dash x, and it is equal to limit of h tends to 0 f of x plus h minus f of x upon h. This is nothing but the expression for f dash x. This is the basic definition of derivative that we've studied in the chapter limit, continuity and differentiability. So here our fx is e raised to power x, so f of x plus h would be e raised to power x plus h. It can be written as e raised to power x into e raised to power h, because when the base is same and power is different, then power get added. So this e raised to power x plus h can be written as e raised to power x minus e raised to power h. Okay, now we will try to find out the f dash x. F dash x, that is d of dx e raised to power x, that is f of x plus h, that is e raised to power x eh minus e raised to power x. Okay, upon h, limit of h tends to 0. Okay, now if we take e raised to power x common, it would be limit h tends to 0 e raised to power x. Here it would become e raised to power h minus 1 upon h. Okay, so what we need to do now is that if we are able to find the limit of this function, then we would be able to find the differentiation of fx. Okay, so let's first find out the limit of h tends to 0 e raised to power h minus 1 upon h. Okay, if we find out the limit of this function, then the f dash x is nothing but the value of limit into e raised to power x. So if you see it, if we put h equals to 0 here, e raised to power 0 minus 1 upon 0, e raised to power 0 is 1 minus 1 0 by 0. So this function is in the form of 0 by 0. So how do we find the limit of function which has the form of 0 by 0? We use a special rule that is called L'Hospital rule. And what does this rule say? This rule says that if you want to find out the limit of a function and it is getting in the form of 0 by 0, then you need to differentiate numerator as well as denominator with respect to h and put h equals to 0 at the end after differentiating. So we will do that only. So after doing this, limit h tends to 0, differentiation of e raised to power h minus 1 with respect to h would be e raised to power h, and differentiation of minus 1 would be 0, and differentiation of h would be 1. And now we will put h equals to 0 here, so e raised to power 0 equals to 1. So what do we see here? We saw that the value of limit of this function is 1. So what will be the f dash x? F dash x would be e raised to power x into 1 equals to e raised to power x. So we proved that differentiation of d of dx e raised to power x is nothing but e raised to power x only, and from this expression we are getting e raised to power x only.